Projectile Motion Series M&M Quiz 2161. Welcome to hecanhelp.com. A projectile is launched at 40 meters per second. The initial velocity vector makes an angle of 60 degrees with respect to the horizontal. Assume no air resistance and constant acceleration. What is the vertical displacement from the point of launch at the 2-second mark? Is it A, 88.88 meters? Is it B, 12.08 meters? Or is it C, 49.68 meters? Positive x is defined as to the right, positive y is vertically up. So at t is equal to 2 seconds, what is the vertical position of our projectile? So if acceleration is a constant, then we can use the equations of kinematics. And one of those equations that you know is change of y, that is the vertical displacement, and that is equal to initial velocity along the vertical times time plus 1/2 acceleration along the vertical. Acceleration along the vertical, positive x is defined as to the right, positive y is vertically up. So what is the acceleration along the vertical? Negative 9.8 meters per second per second. That is the acceleration due to gravity. And time is 2 seconds. So t is equal to 2 seconds. So we know v initial y sine 60 is opposite side to 60, which is the y component, divided by hypotenuse. Hypotenuse is 40. So y component divided by 40. So what do you get for the y component at the start? 40 sine 60, and that is 34.64 meters per second. Once you have the y component, we now have everything. We have v initial y, we have time, we have acceleration along the vertical, and we have time, so we can do this. Substitute all those numbers that we know. Initial velocity along the vertical is 40 sine 60, and that is 34.64, and that's what I have here. V initial y times time is 2 seconds, plus acceleration along the vertical. Remember, acceleration along the vertical, positive x is defined as to the right, positive y is defined as vertically up. So with respect to positive y, acceleration due to gravity is pointing down. So that's the reason why we have negative 9.8. So acceleration along the vertical is negative 9.8 meters per second. And this is time squared. And do the algebra and we get 49.68. It is vertically above the horizontal line containing the launch point, 49.68 meters. So if you draw your projectile like that, then at t is equal to 2 seconds, where are we? At 49.68 meters above the launch point, vertically above. That's the reason why we use the word vertically. All right, that's one way of doing it. Another way of doing it is, you know that change in y is equal to average velocity along the vertical times time. We know the initial velocity along the vertical, and what is that? It is 40 sine 60, and that is 34.64 meters per second. Do we know the final velocity along the vertical? We don't know, but we can find that out. By the definition, you know that acceleration is equal to change of the vertical velocity component divided by time. From that, we get v final y is equal to v0 y plus acceleration along y times time. So what is final velocity? We don't know. Initial velocity along the vertical is 40 sine 60, and that is 34.64. Acceleration along the vertical is negative 9.8. Time is 2 seconds. So this all go together. So what do we get? 15.04. We have initial velocity along the vertical. We have final velocity along the vertical. That's after 2 seconds. And we have the time, which is 2 seconds. So now your change in y is equal to average velocity along the vertical times time. Average velocity along the vertical is 34.64 plus 15.04. Average is plus divided by 2. So 34.64 plus 15.04 divided by 2, that is your average velocity times time times 2. And what do we get? 49.68. So that's what I did on the right side. You have the initial velocity along the vertical, v0y. And we have the final velocity along the vertical, 15.04. And we have the average velocity along the vertical, 24.84. It is positive. Average velocity times time gives us the vertical displacement. So 24.84 times 2, and that is 49.68 meters. We get the same answer. So at t is equal to 2 seconds, change in y is equal to 49.68. And this is George Mathew, always by your side. Good luck.